Hey class, in today's lesson we're going to talk about sum and difference formulas, which is found in section 5.4 part 2. Our objective is to use sum and difference formulas to verify identities and to solve trigonometric equations. So in example 5, proving cofunction identity, our first job or our first priority in this problem is to prove the cofunction identity that we see below. Okay, so as a reminder, what I see technically is on the left-hand side, because we're going to try and prove that the left side equals the right-hand side. Again, that's the cofunction identity that we have, and we want to prove that it equals sine. So you can actually use a difference formula to do that. So if you remember cosine's formula, don't know how I did that. Cosine's formula for difference would be cosine u. Let me just go ahead and write it, sorry. So cosine u sine v plus sine u sine v. Okay, so if that's the case, then what we really have is cosine of pi over 2 times sine of x, and that's cosine. So cosine of x plus sine of pi over 2 and then sine of x. Okay, what that will leave us is cosine of pi over 2, as a reminder, pi over 2 is up here. Cosine is the x value, so the x value there is 0. So 0 times cosine x plus sine at that same angle is 1, so this would be 1 times sine x. Those cancel, so you're left with sine x finally equal to what we wanted, which is sine x. Okay, in example 6, we're going to simplify tangent of theta plus 3 pi. Okay. The sum formula for tangent, as a reminder, is tan u plus tan v over 1 minus tan u tan v. So for us, tangent u would be tan theta plus tan 3 pi over 1 minus tan theta tan 3 pi. The thing is, 3 pi, this would be 1 pi, 2 pi, so 3 pi is over here. Tangent, remember, is y over x, so this value over here is -1, 0. So tangent would be opposite over, or y over x, that'd be 0 over -1, which is 0. So this is really, any place I see a tan 3 pi, it's really a 0. So this is a 0, and this is a 0, but this bottom part is saying 1 minus tan theta times 0, which makes the whole thing 0. So we're left with tan theta over 1, which is tan theta. And we're done. Let's look at our next one. We're asked to simplify. Again, cosine's difference formula would be cosine u cosine v minus sine u sine v. Okay, so cosine u would be cosine theta, and then cosine of 3 pi over 2 plus sine of theta, sine of 3 pi over 2. As a reminder, 3 pi over 2 is down here. That ordered pair is 0, -1. So we would have cosine theta, and then cosine of 3 pi over 2 is times 0, plus sine theta times sine of 3 pi over 2 would be -1. So in the end, we're left with negative sine theta. Let's look at our last problem. So in example 8, we are asked to find all the solutions of sine of x plus pi over 4 plus sine of x minus pi over 4 and set that equal to -1. Not gonna lie, this is gonna take a while. With this, it's very beneficial if you know your formulas, because if you know your formulas, then we don't really have too much work to do. So let's start with the first one, and I'm going to put it in red so it's a little different in color. So dealing with this portion, sine's formula, remember, is sine u cosine, sine u cosine v plus cosine u sine v. So that's going to give me sine x, because I don't have enough space to write it, so that's sine x cosine of pi over 4 plus cosine x sine of pi over 4. Okay, that's the first half. The second half is another problem, but this time it's difference. So you will do sine u cosine v minus cosine u sine v. So that'll give us plus, because this was plus, so plus sine x cosine of pi over 4 minus cosine of x and then sine of pi over 4. And it's going to be equal to -1. So let's start working these piece by piece. If we simplify, that would give us sine of x cosine of pi over 4 square root of 2 over 2 plus cosine of x and sine of pi over 4, again, is square root of 2 over 2 plus sine of x and cosine of pi over 4, which again is square root of 2 over 2 minus cosine of x and sine of pi over 4, which is square root of 2 over 2. Okay, what's going to happen is that the cosines will cancel because they are opposites of one another, positive and negative. So we're actually left with 2 sine x square root of 2 over 2. And it's still equal to the -1 that we were given originally. So to solve for x, we would divide by 2 on both sides so that they cancel. And I'm left with sine x of square root of 2 over 2 equal to -1/2. So the question therefore just is asking you, sorry, and I actually need to go a step further. Let me actually back up a bit. The 2's actually canceled in another spot, so I'm actually not dividing by 2. Sorry. These 2's cancel. There we go. So we're left with sine x of square root of 2 equal to -1. So if we just want sine x, we would then divide by square root of 2 on both sides. So we're left with sine x equal to -1 over square root of 2. We usually don't leave it like that, so we're going to rationalize. And it's going to leave us with sine of x equal to negative square root of 2 over 2. So the question then asks you is, where would you have a negative ratio of negative square root of 2 over 2 for sine? Well, first of all, sine is negative in the third and fourth quadrant, so 1 and 2 aren't available. And square root of 2 over 2 refers to a pi over 4. So the pi over 4s that are located in quadrant 3 and quadrant 4 are x equals to 5 pi over 4 and 7 pi over 4. And those are your final answers. Guys, again, if you have any questions, again, please be sure to come see me for tutoring.